Treatment recommendation has been studied for long history. The task of treatment recommendation is to give proper medications for patients based on their diseases and personalized information. Early treatment recommendation methods construct expert systems to predict medications, but it heavily relies on knowledge from doctors and is difficult to achieve personalized medicine. Instead of highly depend on knowledge, a set of data-driven researches arise. For example, supervised learning and reinforcement learning for prescription. Supervised learning-based prescription tries to minimize the difference between recommended prescriptions and the doctor prescriptions. Unfortunately, the ground truth of good treatment strategy is unclear in medical literature. More importantly, the original goal of clinical decision also considers the outcome of patients instead of only matching the doctor prescriptions. Reinforcement learning maximizes evaluation signal, which indicates cumulative reward from survival rates. However, without knowledgeable supervisors, the system may recommend treatments that are significantly different from doctors, which may cause unacceptable risks. In fact, as a real-world patient record shown in this figure, the x-axis represents the timeline from admin time 12 to discharge time 17 of the third day. Each icon represents a prescribed medication for this patient. Treatments for this patient vary dynamically over time with accruing observations. We find that treatment for the patient requires multi-stage decision-making. This problem is similar to reinforcement learning. Thus, we propose supervised reinforcement learning with recurrent neural network, which fuses reinforcement learning and supervised learning into a synergistic learning framework. To reflect the clinical practice, we regard the treatment recommendation as a sequential decision process. Actor is used to recommend the treatment. Critic is used to evaluate the treatment performance. In addition, we consider the prescriptions of doctors as a supervisor to learn a robust policy. We observe our model has a more clear relative correlation between expected returns and mortality rates than baselines. What can we do now? For example, given a patient with these diseases, which medications will our model recommend? Let's see the answer in our paper.